The main intention today here is I want to give you an update on the EVGI working group, and I would like to provide you with some basic information, what we're currently doing, and but to understand also Honda's engagement in this group, I would like to start a little bit with some thoughts about the energy market itself. So Honda's vision for 2030 is actually to drive the advancement of mobility and enable people everywhere in the world to improve their daily lives, where mobility plays a big role, obviously. So we have 32 million customers, with the US being a major market, and the instance that Honda provides just much more products than just cars, I think calls out to think in terms of mobility, holistic mobility ecosystems, and this is why this working group, especially in the energy field, is such a good fit. So this broad mobility portfolio we have is an interesting foundation for a diverse mobility ecosystem. So especially the energy product space is growing in that ecosystem apart from the vehicle products. And so, for example, the mobile battery pack, which is a swappable battery you can use for several electrified products, or the power manager, which is a bidirectional charging station. These kind of products are kind of a logical next step to provide the customer experience, the seamless experience in an electrified mobility ecosystem, and to give our customers more convenience in that regard. And so especially in Europe, where I'm located, we have already several initiatives going on in the form of pilots, mainly for initiative for energy management. So, for example, demonstrations with energy aggregators, and also we're curating or crafting charge time dependent tariffs, and piloting this for our customers, and especially, of course, owners of electric vehicles. So, for example, in Europe, a centerpiece is the Honda E, which is coming soon. And so the energy management system for us involves basically three elements. We have a so-called smart unit, which is the hardware or the elements needed for the energy transaction, for the exchange. The management network, which consists of these smart unit cells. And then, of course, we want to be also aware of the grid and the needs of the grid and the status of the grid. And as you can already see, this will fit quite well with the use cases for EVGI that have been mentioned already, which I will go into, have a deeper look. So now, for an EMaaS platform or an electrified mobility as a service platform, these elements here would come together. You have the energy services, which we plan to provide to customers. So these can be optimized energy tariffs, but also tariffs which support ancillary services. Then, of course, the usage of the products, the resulting prediction of the supply and demand and other factors, and then, of course, the state of the grid. And this all comes together in a central in a platform here, and of course we also would like to forward certain incentives then to the customer. So I'd like to look a little bit about the how blockchain, in my opinion, can contribute to better energy services. So. Basically, I think, as you know, there are two trends right now which make blockchain a good fit for the energy market. We have a rise of production of decentralized renewables, and at the same time, with the increasing market democratization, we basically, consumers become prosumers, and they demand more rights in this ecosystem, and they demand the tools to control their products and their electrified products, and then also their self-produced renewable energy. And so the blockchain, what can the blockchain do here? It can easily create these tools I mentioned that prosumers may demand to empower them to directly participate in an energy ecosystem. So examples of this can be the trading of energy, the management of V2G on V2 house applications, renting charging infrastructure, generating and receiving green initiative points, for example, or keeping track of the carbon footprint. So such a blockchain will probably look like a dedicated network maintained between business partners. But this is the big advantage here, or the big expectation, that blockchain here will become a big enabler for smoother business processing and easier, more secure cross-organizational collaboration. This is actually the key point. You need a multi-partner environment, as we have identified already in talks before. So, and of course, also this was mentioned, I think this is a very important design factor, apply the technology actually it doesn't have to be a 100% based blockchain product, apply it actually where it makes sense and brings value. So in secure storage and processing of transactions, the access control, and automation of frequently occurring operations in the energy market. So I want to talk a little bit about a couple of use cases. These are not all use cases. I think it's just a good representation, and you will see later on some of them are we are covering in the EVGI working group. So at first we have the EVGI. So this can be tariffs to where a customer basically is willing to provide so that. Basically willing that the EV doesn't charge all the time, so the charging can be interrupted based on the demand-supply situation, or for example to avoid or to apply peak shaving in a certain facility where he's charging, and the effect here can be a tariff cost down. So V2G is then even more complex, requires also bidirectional charging hardware, but this enables ancillary services which can even contribute more to grid stability, like frequency regulation is a very common use case, and also here the customer by helping out to stabilize the grid can be incentivized or benefited by special tariffs. So as Alex said yesterday, since an EV moves around, even so the cars can effectively become flexible batteries for the distributed power grid, because they can offer these services in a different part of the city, for example. So the next use case is pretty straightforward, is basically the peer-to-peer energy exchange, or if you produce energy by yourself and you do not want to feed it back into the grid, you can offload this excess renewable energy to some other peer who is in need of energy. The infrastructure sharing, this is more known from the sharing economy, basically renting out or co-owning and sharing and so on of chargers and so on. The energy traceability, so a very convenient use case here is to virtually consume green energy. Maybe you produce at home at some other point later in time, and maybe even some other location. So the blockchain with a contract can help here to control the billing of this. And of course, you can design green initiatives, for example, by incentivizing or rewarding the customer if he uses green energies, and he can then spend these tokens for within the product ecosystem for goods and services and so on. So, but there are also some challenges or aspects I think need to be considered when designing a blockchain-based energy system. So I will not go into detail. I will just mention a few. So of course this is a big challenge, the integration with obviously existing legacy systems. The decentralized approach has to fit into a company's energy business strategy. Societal and environmental factors, of course, regulation in the energy field is a big aspect. There's a lot of legacy regulation, very complex. Generally, the energy market is digitalizing very slow. Generally, DLTs are perceived that they still have not passed the hype cycle, and also there's sometimes a misunderstanding that the DLT will basically replace every economic system, but actually it's just about creating new tools and improving tools for better service processing and easier cross-partner collaboration. So on the technological side, of course, there are many things to consider. What is the right protocol? Innovation is moving very fast here. What kind of hardwares do we have? How capable are meters, for example? you're familiar with this triangle between decentralization, scale, and security. Energy consuming consensus algorithms is a big problem. Generally, the immutability or non-updatability of data and contracts. And yeah, of course, if you want to attract actual developers and third parties, you need well-crafted APIs which appeal to a broad developer base. And so on and so forth. So in the ecosystem, as I said, very, very important factor, whatever you do, please make sure that you have your multi-partner environment in place. The integration with other, also open energy management platforms, which we've heard of in the past, is very important. Token design is a big issue or a big challenge. And thank you. And lastly, there's the question, what kind of contact does the user have with the blockchain and how to still offer the user a seamless and delay-free user experience. So now finally getting to the electric vehicle grid. So it has been mentioned so far. So our goal is to create standards of interoperability of the electrical vehicle ecosystem so that other partners or other actors on the energy market can easily adopt. We define key energy use cases driven by the members, what the members have brought to the table. As Lucy pointed out, this is very important. And and we're also looking at VID, so we try to analyze and possibly reuse items for EVGI standardization to not reinvent the wheel. So identity, of course, is a big influence here, and so that the concept of a digital twin, a digital representation of a vehicle, you can also apply it to other peers in the energy sector, and this is why we're closely looking at the VID work so far. So a quick overview, just to let you know, these are not all the members, this is just a selection, so the group is chaired by GM and co-chaired by me. R3, as you may know, is an enterprise blockchain software firm which coordinates the development of Corda and Corda Enterprise. So Filament and IOTA, they have been introduced already. Blockchain at Berkeley, is an academic organization at UC Berkeley. PG&E is gladly covering the utility side, and CAR is a vehicle remarketer which is covering also the fleet perspective in EVGI. So we have like a very diverse group of partners, which is a very good starting point. So, I will not go into detail just to know where we are. Basically, in the middle of the entire life cycle of a one-year life cycle of a MOBI working group. Basically, right now here, carving out business requirements, technical requirements, and starting soon with the architectural and governance documents. And but this is taken from the project charter. Those of you familiar with that, you may know this life cycle. So. I just would like to give you a small insight of samples of work, so you get a good feeling of what we're currently working on. This is not complete, but I want to show you the use cases we have defined, some requirements, and some data attributes. So the use cases, Lucy has mentioned them already, so we are looking at V2G, and the sub-use cases would be to offering a vehicle battery to the grid for grid services, and also selling locally generated excess energy. Tokenized carbon credits is about defining or the composition of a credit. We're thinking about wallet functions and possible incentivation. And on the peer-to-peer energy exchange side, here the group has focused on the leasing or the renting of chargers for public pay-per-use. I think no need to go into detail here. So these are just example requirements, typical requirements we have identified for these use cases. So for example, V2G, this is kind of an obvious one. The vehicle itself shall have an identity against an energy peer, but also if you introduce more granularity, then for assets within the vehicle, the battery shall have a digital representation on the blockchain, and so on. So the blue ones are candidates to extend VID or to transfer VID concept into energy peer. These slides will be distributed, so you can check later on. And that's what we're currently doing, the data attributes, so these are also examples. Given the time situation, I will just come to the conclusions. So the EVGI working group represents a very good mix of actors active in an energy ecosystem, and the choice of initial use cases reflects this diversity. The current standardization work in EVGI focuses on initial building blocks to identify and represent typical elements in an energy ecosystem. And the first BID standard from July is considered where it actually adds value. And so, yeah, that's my talk. I wanted to, as I said, give you an insight of current status of the EVGI working group. And if you have questions about the work, let me know, let some of the members know. And yeah, thank you very much.